Hello everyone, my name is Chen Liang. Now we talk about gas transportation. There are two forms of oxygen and carbon dioxide in the blood: transportation, physical dissolution, and chemical communication. In physical dissolution, the oxygen is 0.3 mm in 100 mm blood, but the carbon dioxide is 2.9 mm and 98.5% oxygen bind to hemoglobin. Carbon dioxide is 94%. The bond between hemoglobin and oxygen is a chemical reaction. The reaction is very fast and reverse. Elements are not needed in this reaction. The bonding between oxygen and the ferrous ion of hemoglobin is oxygen but not oxidation. 1 gram hemoglobin can bind 1.34 to 1.39 milliliter oxygen. Deoxyhemoglobin is dark red. Oxyhemoglobin is light red. Oxygen capacity is minimal amount of oxygen that will bind with hemoglobin in 100 milliliter blood. Oxygen content is actually amount of oxygen that binding hemoglobin in 100 milliliter blood. Oxygen saturation is oxygen content to oxygen capacity. Cyanosis is deoxyhemoglobin exceed 5 grams hemoglobin in 100 milliliter blood. The color of carbon monoxide bind hemoglobin is cherry. If there is low oxyhemoglobin, the fish is pale. Now we will talk about oxygen hemoglobin dissolution curve. It denotes that the relation between oxygen partial press and oxygen saturation. It is an S-shaped curve like this. This curve has following characteristics. If the pressure of oxygen between 16 to 100 millimeters mercury, there is only 10% difference in the amount of oxygen carried by hemoglobin. At 16 to 100 millimeters mercury, the pressure of oxygen changes, influencing a little oxygen saturation. At 16 millimeters mercury of oxygen pressure, hemoglobin saturation is still high at 19%. At 100 millimeters mercury of oxygen pressure, hemoglobin saturation is still high at 97.45%. Then we can see the steep middle portion. The pressure of oxygen is between 14 to 16 millimeters mercury. In these steep middle portions, oxygen hemoglobin saturation is between 75 to 19%. Oxygen content at 100 millimeters mercury of oxygen pressure, there is 19.4 millimeters oxygen in 100 millimeter blood, and at 40 millimeters mercury, there is 14.4 millimeter. The released oxygen volume is 25%. Then we can see the steep lower portion. The pressure of oxygen is between 15 to 14 millimeters mercury. In this steep lower portion, oxygen hemoglobin saturation falls quickly from 75. Oxygen content at 15 millimeters mercury of oxygen pressure, there is 4.4 millimeter oxygen in 100 millimeter blood. The released oxygen volume is 75%. When hemoglobin oxygen saturation is 15, the pressure of oxygen value is called P15. P15 is an indication of affinity of hemoglobin for oxygen. At higher P15, the affinity is less. S-curve shift right. There are many factors affect P15. When pH value decrease, carbon dioxide increase, P15 increase, the curve shift right. The affinity of the hemoglobin for oxygen decrease. pH value increase, carbon dioxide decrease, P15 decrease, the curve shift left. The affinity of hemoglobin for oxygen increase. The influence of carbon dioxide and acid on the release of oxygen is known Boyle effect. In the lung, carbon dioxide from blood to elevate the pressure of carbon dioxide in capillary blood increase. pH value is increased. The curve shift left. The affinity of hemoglobin for oxygen increase. So more oxygen bind on hemoglobin in the tissue. Carbon dioxide from tissue to capillary blood. The pressure of carbon dioxide in capillary blood decrease. pH value is decreased. The curve shift right. The affinity of hemoglobin for oxygen decrease. So hemoglobins release more oxygen. pH value is decreased. The curve shift right. pH value is increased. The curve shift left. The temperature increase. The curve shift right. The affinity of hemoglobin for oxygen. If there are more 2,3 dpg, the curve shift right. The affinity of hemoglobin for oxygen decrease. 2,3 dpg is a product of glycolysis. The divinate ions became trimmer ions. The affinity of hemoglobin for oxygen becomes 0. Carbon monoxide can effectively block the combination of oxygen with hemoglobin, resulting in tissue hypoxia. Carbon monoxide also inhibits the release of oxygen. Then we will talk about carbon dioxide transport. There are 3 forms in carbon dioxide transport: chemical communication, carbonyl hemoglobin, bicarbonate. In tissue, hydrogen ions in the blood promote the release of oxygen. This is the Boyle effect. In the lung, increase of oxygen binding hemoglobin in blood promotes the release of carbon dioxide. In this curve, the increase of oxygen partial pressure makes the curve shift to the left. It promotes the release of carbon dioxide. The last, we will talk about respiratory regulation, respiratory center, and the formulation of the respiratory rhythm. And there is respiratory reflex regulation, the chemireceptive reflex. There are pulmonary inflation reflex and pulmonary deflation reflex. Pulmonary stretch reflex: when cut vagus nerve, the respiratory movement becomes deep and slow. Protective respiration reflex, cough reflex, and sneeze reflex, and other perceptive reflex. That's all. Thank you.